Hello guys, so today I'm going to be going over how to write the proof for this statement right here. So it says the negative of any odd integer is odd. Now, the first thing you want to do when you're doing a direct proof is turn the statement into an if-then statement. So there's one variable, and we could say if, let's say for some reason we choose n, it could be any letter. If n is an odd integer, then the negative of n, which is negative n, is odd. So this right here is the if-then statement of this statement up here. Now, write the proof. So the first thing you do is you write something along the lines of suppose, and then you write the if part of the if-then statement. So suppose n is an odd integer After we write the first sentence, we now want to address all of the definitions. So here we have the word odd that needs to be defined. Integer doesn't need to be defined, but odd does. So here is the definition from the textbook. An integer n is odd if and only if n equals twice some integer plus 1. So n is odd when there exists an integer k such that n equals 2k plus 1. So we could say by the definition of odd, n equals 2k plus 1, where k is an element of the set of integers. What you want to do next is address the negative n, because we are trying to prove that negative n is odd when n is an odd integer, or if n is an odd integer. So now we can say then negative n equals the negative of 2k plus 1, and that equals negative 2k minus 1 when you do the distributive property, simple algebra. So now we have to ask ourselves, how do we turn 1 into negative 1? We subtract 2. So this is equal to negative 2k minus 2 plus 1. So that would equal, if we factor out a 2, negative k minus 1 plus 1. And I knew to do this because we're trying to prove that negative n is odd, and the definition of odd says it's some number that could be represented in the form 2 times an integer plus 1. So negative k minus 1 is an integer because integers are closed by multiplication and subtraction, meaning if you multiply integers together, the product is integers. So now we could say let r equal negative k minus 1. So negative n equals 2r plus 1, where r is an integer. All I did was took this, represented by r, and then wrote negative n equals 2r plus 1, where r is an integer. And then I could say this is the definition of an odd number. Thus, negative n is odd. And then you put the little square symbol at the end, signifying that you're done with the proof.